Hello everyone. In last video we looked at the question longest substring without repeating characters and solved it with brute force approach by calculating all possible substring and determining the substring with maximum length without any repeating characters. Today we will look at solving the problem with optimal approach that will have the time complexity O of n. To land ourselves onto optimal solution, let's look at our previous brute force approach and try to understand what repetitive and unnecessary calculation we are doing to identify room of further improvements. In brute force approach, we used a sliding window where the ith pointer slided the left side of the window and jth pointer slided the right side of the window. With help of this sliding window, we created the substring and for each substring, we did the duplicate character check. The substring creation and duplicate character check operation takes O of n square time. This contributes to the O of n cube time of our overall code. The duplicate check that we do for the substring is a repetitive calculation. Let's try to understand how the duplicate check in brute force approach is repetitive calculation by looking at an example. Let's replace I and j pointer with s and e pointer representing start and end of the sliding window. Let's say S is at 2 and E is at 4. So the current substring would be MZU. We'll do a duplicate check on this substring. And then we'll increment our E pointer. So the new substring would be MZUZ. We'll do a duplicate check on this new substring. You see, the duplicate check is a repetitive operation because for MZU in this new substring, we had already checked if there are any duplicates or not in the previous substring. So instead of rechecking the duplicate characters in whole substring, what we should do is we should check if the current character that E is pointing to was it present in the previous substring or not. We can achieve this by using Hashmap that will maintain the element and its index. With Hashmap, we can convert the O of n square duplicate check operation to O of 1. This is because the lookup time in Hashmap is O of 1. Looking up duplicate characters using Hashmap in this solution is similar to optimal approach of lead code problem number 1 to sum, where we stored mapping of the number and its index to look up the complement pair. This solution is hard to come intuitively to beginners. I remember encountering this problem in a tech interview when I was a beginner and was unable to solve it with optimal approach. In my opinion, this solution can only come intuitively if one has solved such similar problems. Let's visualize the optimal solution sliding window with Hashmap by taking the example test case where input string is TMMZUZ and expected output is 3 because longest substring with unique characters in input is MZU of length 3. We will initialize last seen variable to empty hashmap and max length variable to 0. We will initialize s and e pointer to 0. We will compute length of current substring t, which is 1. We will update the max length value from 0 to 1. And then we will insert the current element and its index in last seen hash map. We increment the e pointer. We will compute the length of the current substring tm, which is 2. We'll update the max length value from 1 to 2. We'll insert the current element and its index in last seen hash map. We'll increment the e pointer. The current element m which e is pointing to is present in last seen, and the index of the character m is 1, which is in the sliding window between the s and e pointer. This means that the current character is repeated. This is exactly what we talked about, checking if the current character is present in the previous substring using the hash map. So now we'll have to move the start pointer of our sliding window. We move the start pointer to index of repetitive character plus 1. will compute the length of the current substring m, which is 1. Max length, which is 2, is greater than 1, so it will stay at 2. We'll update the index of the current element in last seen hash map. We will increment our e pointer. We will compute the length of the current substring mz, which is 2. Max length will stay at 2. We will insert the current element and its index in last seen hash map. We will increment e pointer. We will compute the length of current substring mzu, which is 3. Max length will update from 2 to 3. We will insert the current element and its index in last seen hash map. We will increment the e pointer. The current element z, which e is pointing to, is present in last seen, and the index of current character in last seen is 3, which is in the sliding window between the s and e pointer. So we will now have to move the start pointer of our sliding window. We move the start pointer to index of repetitive character plus 1. We will compute length of current substring z, which is 1. Max length will stay at 3. We will update the index of current element in last seen hash map. Now s and e have reached the end of the string, so we return the value of max length, which is 3. Let's code the solution. We'll initialize last seen variable to a empty hash map. We'll initialize start pointer of the sliding window to 0 and max length to 0. We'll write a for loop to iterate through all characters in input string, and the enumeration number will represent the end pointer of sliding window. We'll check if current character is present in last seen and start of sliding window is less than the last seen index of current character, then the character is repeated. Hence we'll move the start pointer to the last seen index of current character plus 1. We'll now insert the current character and its index in the last seen hash map. We'll calculate the length of the current substring, which would be equal to end minus start plus 1. We'll now update the max length, which would be equal to max of max length and length of substring. Outside the loop, we'll return the max length. We'll submit the solution. The solution got accepted. Let's do a time complexity space complexity analysis of our code. The time complexity of our code is O of n because we are using one for loop to iterate through all elements in input string. The space complexity of our code is O of n because of the storage taken by last seen hashmap variable to store characters and their indices. Thank you for watching the video. Stay tuned for upcoming coding videos.